quantity. I think we solved this one before. But let's try it. Okay. We are starting from question. It says that a company manufactures cartons of distilled water. The management accountant has reported that the daily total cost of producing 250 cartons of distilled water is 4,500. Please, when you hear total cost, what comes in mind? Total cost. You see, I told you total cost has to do with what? Variable cost plus what? Fixed cost. And the variable cost is the variable cost per unit times quantity, and the fixed cost will always be given. So if they say total cost, this is what comes in mind. And this is what? A line or equation of a line. So a linear equation, which looks like this. You should always remember. Okay. So the management accountant has reported that the daily total cost of producing 250 cartons of distilled water is 4,500 and 6,000 when 400 cartons of distilled water are produced. The accountant has further indicated that there is a linear relationship between the total cost and the cartons of distilled water produced. That's Q, which she reported as TC is equal to what? A plus BQ. So it's the same thing as this. But they decided to write it this BQ plus A, where A is likened to C, which is also the fixed cost. B is M, which is also variable cost per unit, and Q is X, which is the quantity. And I told you that anytime a linear equation question is given, the two things you are supposed to find is your M and the C. That's the variable cost per unit and the fixed cost. So I told you how to find the variable cost per unit. Variable cost per unit, or the M, is equal to what? Y2 minus Y1 over what? X2 minus X1. Or if you are using total cost, total cost 2 minus the total cost 1 divided by second quantity minus the first quantity. So to get our variable cost per unit, we know our second total cost was 6,000. The first one was what? 4,500, and the second one is 6,000. So 6,000 minus 4,500 all over 400 minus 250. So 400 minus 250. Please, any question? Can I bring my any question? Hello?
Hello.
Yeah, I'm asking you.
No, please. I don't
Yeah.
know. I'm thinking for myself.
Okay, so 6,000. You are confused. Hello?
No.
Okay. Okay. So we get the variable cost per unit as 10 cedis per unit. So it means that the variable cost for producing 1 unit is 10. That's the M. We found the M. Always M is the variable cost or the slope. And I told you that with M, we use this formula, y2 minus y1 by x2 minus x1. So anytime you see total cost function, you should psych your mind that we are going to find the variable cost per unit and the fixed cost. And already the question has told you that there is already an established relationship between the total cost and the quantity. So now that we know our M, we can use one activity level where maybe quantity is equal to 250 and the total cost is what? 4,500 cedis. So using this activity level, total cost is equal to what? Variable cost per unit times quantity plus the fixed cost. But we know our total cost to be what? 4,500. We know our variable cost per unit to be 10 cents. So 10 times Q. And now at this activity level, we know our quantity. And our quantity is what? 250. So 10 times 250. Okay. 250 plus the fixed cost should give you the total cost. So this time we get 4,500 being equal to 10 times 52 give you 2,500 plus the fixed cost. From here, we do change of subject. We make fixed cost the subject. We bring this here. We get 4,500 minus 2,500 being equal to the fixed cost. So therefore, 2,000 cedis is equal to what? The fixed cost. Please, you understand? So our fixed cost, therefore, our linear equation is equal to 10 Q plus 2,000. That's the total cost function. Please, you understand?
So we will maintain the 10Q.
Yes, you see, this is what we are supposed to find. You see, I didn't even read the question, I didn't finish reading the question, but I know the first requirement determine the total cost function. The question says that a company manufactures cartons of distilled water. So the cartons are the quantities they manufacture. Now, the management accountant has reported that the daily total cost for producing 250 cartons of distilled water is 4,500 and 6,000 when 400 of distilled waters are produced. The accountant has further indicated that there exists a linear relationship between the total cost and the cartons of distilled waters produced. That's the quantity, which she reported as total cost is equal to A plus BQ. Now, the first question is saying determine the total cost. And I'm saying that when you are being asked to determine the total cost, always you should know how a total cost function looks like. It looks like a straight line. Y is equal to mx plus c. And anytime you are supposed to find your n, which is the slope, and the c. And here m is likened to the variable cost per unit. And the c is the fixed cost in its application. Please, you understand? And I told you that m can be found as y2 minus y1 over what? X2 minus x1. Here in this case, it becomes total cost 2 minus total cost 1 divided by the quantity 2 minus quantity 1. Please, you understand?
Yes.
So when you find your m, like I did, variable cost per unit is equal to 6,000 minus 4,500 divided by 400 minus 250. Now look at this was the first quantity, 250. And this was the total cost, the first total cost. And this is the second total cost. And this was the second quantity. That's why I said 6,000 minus 4,500 divided by 400 minus 250. You can see it. So when you get your variable cost per unit, you insert it alongside with one activity level. This is one activity level. And the activity level is when they produce 250, their total cost is 4,500. So we insert that into the equation. That's the 4,500. The variable cost per unit is 10 and the 250. That's the quantity. So that we'll be left with only fixed cost to find. So here from here, change of subjects, then we'll get our total cost. Please you understand?
Yes.
Okay. So when you are done, they said determine the total cost function. And I told you that we just need two things. We need the M and the C. So now that we found M and C, we replace them in the equation. So M is what? 10. We replace it here. And C is what? 2,000. The rest, total cost and quantity, they are variable. They are variables. So we maintain them as they are. So I think we are done for with this question. Let me clean it. Please, I believe you understand. That's for 5 marks. If you can do this in this question, you will go for it went for 5 marks. Okay. Now we go to the second requirement under the same question. It says find the total cost if 500 cartons are produced. Now we have the function. So when Q is equal to 500, that's the B. Total cost will be 10 into bracket 500 plus 2,000. Please you understand? So here we get 5,000 plus 2,000 being equal to 7,000. So therefore, when quantity is 500, the total cost will be 7,000 Ghana cedis. Please you understand? Hello?
From the beginning. So okay, so that's the question. When um Q equals to 500, or is it 800?
500. They are saying that
Okay.
what will be the total cost when 500 cartons are produced?
Okay.
So you just insert the 500, replace the Q by 500 because Q is quantity produced. So when you replace the Q by 500 in the function, then you find the Q. So when you find Q, then you say that therefore when 500 cartons are the total cost 7,000. Please you understand?
Yes,
Yes.
for me. I don't know about the others.
Okay.
We are writing it all. So
Are you done? Please, are you done writing?
Yes.
Okay. We are on the C. Now the C is asking that if the selling price per carton is 15 cents, find the number of cartons the company must produce and sell in order to break even. That's the CI. Now, I told you that break even point in quantity is equal to your fixed cost, right? Divided by what? Contribution per unit. And how do you get your contribution per unit? It is your selling price minus what? Your variable cost per unit. Selling price is 15 cents. Now, variable cost per unit, we got it as 10 cents. That's the one we got here. Okay, 10 cents. So therefore, the contribution per unit becomes what? 5 cents. We know our fixed cost too. Our fixed cost is what? 2,000 Ghana cents. That's it here. So therefore, the break-even point in quantity becomes, or quantity to break even, any which way you write it, becomes your 2,000 Ghana cedis divided by the 5 cedis, which is the contribution. And that will give us 400. Hello, any question? So when they produce 400 cartons and sell them, they would neither make profits nor losses. Hello, please, do you have any question?
No.
Yeah. Do you have any question to this?
No, please.
Okay. Now, they said that the break-even point at a realized profit. And I told you that always when there is a realized profit, you treat that realized profit as a fixed cost. So to break even at a realized profit becomes your fixed cost plus that targeted profit divided by your contribution per unit. Now, you see, the main reason why we are trying to do break even, I told you already about shutdown decision making. That for companies to shut down, it means that their contribution per unit or their contribution margin can't pay off their fixed cost. That's why they shut down. So before they will make a decision, they will make sure that that criteria is established whereby their fixed cost cannot be paid by their contribution per unit, or sorry, their contribution margin. So if you are targeting a profit, then we should make sure that the contribution margin can also cover that profit you are targeting. Do you understand? That's why we add the fixed cost to we add the profit that we are targeting to the fixed cost. We assume it to be fixed in nature. So the fixed cost here is the profit here is 10,000, but we know our fixed cost to be 2,000 plus the 10,000 profit we are targeting, all divided by the contribution per unit. And what do we get? So we get 12,000 divided by 5. That's 2,400. So to target a profit of 10,000, we have to produce 2,400. Let's say to realize, because they use the word to. So therefore, to realize a profit of 10,000, the company must produce and sell 2,400 cartons. Do you understand? Any question? If there is no
So
question,
why is the graph? What is the graph they were talking about?
which graph?
They said question one is graph. Ah, this one is it the IA question?
No, 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 no. This is the
Uh-huh.
first question. Please, you understand this question. Mm.
Um,
Yeah.
Hey, please, are the rest there?
I think Mr. Douglas is sleeping by now, and I don't
They
know.
far gone. Oh.
They've all gone.
They are offline.
Yeah, I'm here, but I'm just not interested in that question one.
Hey,
Oh,
Mr. Douglas, why?
okay.
Oh, I'm here.
Why are you not interested?
Funny enough, if you ask me, I don't know why, but so I wasn't following actually.
Oh,
That
okay.
question one, I was actually dozing off, but I'm back. I'm okay.
Okay. Please, question one is one of the
Barbara, are you there? Yes.
question
Okay.
one is one of the easiest. Unlike question two and the rest, question one is the easiest.
Funny enough, I find question 2 and 3 as the easiest than question 1. I don't know why.
Mm.
Yes.
Please let's see question two. Question two. It says that KFC makes this question. This is linear program. KFC makes two products. Sorry. KFC makes a burger from two ingredients. You have steak and fish. The two ingredients provide different amounts of proteins and vitamins. Now, let me restructure. Hey, I don't like red pen. Oh, hmm. It says that KFC produce two products. Sorry, a burger from two ingredients: steak and fish. Question two. That's KFC. So KFC produce two products: steak and fish. It produces a burger from these two products. Now, it says that they use proteins and vitamins or vitamins to produce that. Now, please, it says that they make burger from two ingredients, steak and fish. Now, the two ingredients provide different amounts of proteins and vitamins. That's what I've illustrated on the table, this table. Now, it says that steak provides 12 units of proteins and 7 units of vitamins. So steak provides 12 units of protein, 7 vitamins. It is very simple. And fish provides 6 units of protein, 5 units of vitamins. So 6 units of proteins, 5 units of vitamins. Now, every time we are solving a linear programming question, we look for what we call constraints. Please, quantitative methods is like cost accounting. Everything in quantity is like cost accounting. Now, we call this topic limiting factors, factor decision making. We are producing a particular product with a limited factor, with a constraint. So that constraint, because it is limited, we would have to prioritize. But just that under this level is not that more of decision making. Okay. So they said that KFC produces two ingredients, steak and fish. And this is how it we illustrate it. Now, read the question. You will see that the paragraph here, It says that the profits per pound of steak and fish are 4 cedis and 3 cedis respectively. Please, profit is not what we are looking for, but it is necessary. Now, listen. It says that KFC wants its burger to contain at most 112 units of proteins. Now, this is the constraint. It says that the maximum number of proteins that should be contained in the burger should be 112, which means it can't be more than 112. At most. That's the meaning of at most. So it means that this protein should be less than or equal to 1012, because the maximum should be what? 1012. Please, you understand? It's a question of. And he says that 70 units of vitamins per pound. So he says KFC wants its burger to contain at most 112 units of proteins and 70 units of vitamins. So that one too is at
102.
most.
It's
Sorry,
102.
102,
Okay.
70, 102, not 112. So he's saying that the maximum proteins that should be contained in the burger is 102. And from vitamins to the maximum should also be 70. So this is the constraint. This is the limiting factor or constraint. Okay, that's a constraint in the question. So always you need a constraint. If you don't have a constraint, which means you are getting it wrong. Now they are saying that KFC makes a profit of 4 cedis on the steak and 3 cedis on the distance. So you can just write the profits here. 3 profits. Now let's see the requirements. A. Define the decision variables for KFC's production problem. It's just 2 marks because it's not difficult. Please, this is not the decision variable. This is how you structure it. Now, this is how you get the decision variables. So the first one, you can say let X be steak and Y be fish. Okay. So wherever you see Y, it means I'm talking about steak. And wherever you see X, it means I'm talking about fish. So for proteins, the decision variable becomes 12x plus 6y less than or equal to 102. And for vitamins, it becomes 7x plus 5y less than or equal to 70. Please, you understand? Now, when you are done, you see that x is greater than or equal to 0. Y is greater than or equal to 0. Add it to your decision variables. You do this for 2 marks. Then you add your profit function. Profit is equal to 4x. That's 4 cedis for steak times 3 cedis for fish. Please, do you understand this? Hello?
Yeah, up to this side.
You understand up to this side? Good.
Mm.
Now, the B. The B is saying that formulate your linear programming for this problem. Solve this model by using a graphical analysis. That's the most important one. You see that one has what? 10 marks. Okay, so let's formulate the linear decision making model. The graphical this thing is very important. Okay, so you assume they are all equal to. Okay, so you say 12x plus 6y is equal to 102. Then you see when x is equal to maybe 0. You know, when x is 0, if x is 0, it means everything at the x side will be 0. 12 times 0 will be 0. So we get 0 plus 6y being equal to 102. So we divide it by 6, we divide it by 6. This cancels this. 6 will go into 102 how many times? 102 divided by 6. That's 17. So y will be 17. So when x is 0, y is 17. That's our first coordinates. You know that this is a line. This thing here is a line. 12x plus 6y being equal to 102. It's a straight line. And a line, I told you that a line is the distance between 2 points. So this is a point on the line. 0, 17. There's a point on the line. And maybe another point could be what we are going to find. So that one we say when y rather is equal to 0. So when y is 0, 12x plus 6 into bracket 0 should be equal to 102. So we'll get 12x plus 0 being equal to 102. You divide it by 12, divided by 12. This cancels it. Our x becomes 102 divided by 12, which is 8.5. So which means that the second coordinate becomes 8.5 and 0. So let's say this is 8.5. This is 0. So this is the coordinates we are talking about. So for this line, we found our 2 points that we can use to draw the line. Because we are going to graph it, so we need to draw the line. And the line occurs at these 2 points. The first one being x being 0, y being 17. The second one, x being 8.5, y being 0. Please, you understand? Just this one. You understand this one before I move
Yes.
on. Okay. So let's go to that. So we do the same for the other equation. We do the same thing. So the other equation, we have 7x, let me see, 7x plus 5y being equal to 70. So we see when x is 0, you know when x is 0, this will give us 0, 5y being equal to 70. We divide it by 5, so y will be what? 5 divided by 70, I think it's 14. Yes, y will be 14. So 14 will come here. Then we say the first point is 0, 14. Then we do the same thing for the second one. So that one too, we say when y is equal to 0. So 7x plus 5 bracket 0 being equal to 70. You know, we get 7x plus 0 being equal to 70. Please, I'm continuing here. 7x being equal to 70, we divide it by 7, divide it by 7. Let's cancel this. 7 will go here, 10. So our x will be what? 10. So the second coordinate becomes x being 10, y being 0. Please, you understand? Now, you see, I said that x is greater than or equal to 0. So you say x is equal to 0, y is equal to 0. I said you assume that they are all equal to 0. They are all equal to 0 from here. You assume that they are all equal to 0. So this is the B. The B, formulate a linear programming model for this problem. Now the C is that solve this model using a graphical analysis. That's what we are coming to. 10 marks. And it is not difficult like you think it is. So let me draft it. This graph is not drawn to scale. The day you guys will do your quanti, I would have to teach you how to use the graph. Okay. Now, you take the first point. Now, first of all, you know x is equal to 0, y is equal to 0. So you just write maybe y is equal to 0. X is equal to 0. Now, this means that this line is part of the analysis. And also this one is also part of the analysis. That's what it means. X is equal to 0, y is equal to 0 means that those two lines are part of the analysis. Now, the first point for the first line was 0.17. So this is the x-axis. This is the x-axis. This side is the x-axis. This side is the y-axis. This is 0. So from year to year, let's say year is 2, 4, 6, 8, 10, 12, 14, 16, 17. Okay. No, 18. Let me put it 8. Okay. So this is the y-axis. So here to 2, 4, 6, 8, 10, 12, 14, 16. Okay, let's do it this way. Now, we plot the first one. The first one is x is 0. So this is, let me use this one. So when they say x is 0, it means that x is here. You can see where my mouse is. And y is 17. So y2 will be somewhere here. You see, I told you that x is equal to 0, y is equal to 0. So it means these lines are part of the analysis. So it means that where the mouse is, that's where our first point will be. And we'll name there 0.17. Then we'll look for the second point. The second point, our x is 8.5 and our y is 0. So x is 8.5. This is x. Being 8.5. This is it. Let's assume this is it. And y being 0, it means that y is still on this line. So that's it. So we name it 8.50. That's it there. Then we rule a straight line because I told you that it's a line. So we have to rule a line. Channel. Please, you understand? Hello?
Hi.
Do you understand?
Yes.
You understand just this
Yes. Yes.
one? Okay. When we are done, we also take the second line. So the second line, this is the second line. And the second line, we got two coordinates, 0, 14, and 10, 0. So the first one is 0 being on the x. This is the x. The x is 0, but y is 14. So this is it. So we put it here. Then we name it 0, 14. And the other one is 10, 0. 10, 0. So the 10, 0 too, we'll identify 10. This is our 10. So 10, 0. This is it here. Because y is 0, but x is 10. So this is it here. Then we draw our straight line to pass through those 2 points. Okay. So the straight line that passes through these 2 points will be this. Please, you understand? Hello?
Yes.
Yes. Okay. Now that we've drawn the line, you know that these are meeting points. Wherever two lines meet, that point becomes a critical point. So you know this one is a critical point because this line, this line, let me show you. This line and this one has met here. So this is a critical point. This one too is a critical point because this and this has met there. So it's a critical point. Also here it's a critical point because two lines have met over there. So you would have to determine that point. Okay. So I think yes should be, let's say, 7 and let's say 7 and 5. Okay. Now this two is a critical point and these are the coordinates. This one too is critical. But we have to use the constraint they gave us. This is where we use the constraint to find the best fits, the points of best fits, or the critical points of best fits that fits the constraint that was given. Now, when you hear greater than or equal to, it means that the line is going this way. Okay, this way. You know that x is greater than or equal to 0, y is greater than or equal to 0. So it means that the line goes upwards. It doesn't go into the negative. That's what it means. Likewise, it means this one too is like this. This one is going this way. This one is going this way. Okay. Now, the first line, this is the first line. This one. This is the first line. This one. This line is the first line. The first line is less than or equal to. So less than or equal to means that it is coming down like this. And this side is coming down. The second line, which is this one, second, is also less than or equal to. So it means that it is coming this side. Now, anytime this one comes to meet the second line, the first line, no, the first line will meet the second line here. So it means that the second line overrides the first line. Because as a marathon, if you are running, you pass the ball, the stick over to your colleague, so that the colleague will continue the race. So the first line here passes it to the second for the second to continue the fight. Now, this one too, the same thing happens here. The first also, that's, I don't know whether you can see. You can't see. Oh, like I'm saying, the first one here will pass the baton to this one. Then he will also use or run with it. So he will take it and be going. Likewise, this side too will pass it to this side. Then this side will use it to run. Now, you know that this side, they are coming this way. They are going up. They are moving towards upwards. These people are moving towards upwards. Okay, this side is coming up. This side is coming up. This side is coming up. Now this side is coming down. 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 This is going up. This is going up. So this is where they meet. And at this point, it's like things are tight. You see, here there will be a struggle, like a fight. That's the critical area. Okay, this side becomes the critical area. Okay, so the critical area occurs at 3 points. That's 0, 14, 7, 5, and 8.5 and 0. Please, this thing is not drawn to scale. I would give you more explanation when we meet in person. Okay. Now, from here, we say the profit function is equal to 4x plus 3y. Now, the profit function will give you a criteria whether to maximize profit or to minimize profit. So here it says that KFC wants its burger to contain at most 102 units of proteins, 70 units of vitamins per pound, and must be as affordable as possible. So if they want affordability, it means that they are not interested in profits. If they want it to be profitable, that's when they want it to be expensive. So as affordable as possible would lead to the least profit. So they want you to find the least profit. So you put them in the equation. So the first point says that 4x is 0, y is 14. So profit becomes 3 times 14, which is 42. The second one, x was 5 and sorry, this coordinates I didn't write it well. X was 5, y was 7. So 5 plus 7. So 4 times 5 is 20 plus 3, 7, 21. So plus 21, which is 41. So this one is giving us lesser profits than the first one. Then we do the last one. That one to profits. We have 4 times 8.5. That's the x. And the y is 0. So 4 times 8.5 plus 3 bracket 0. So 34. So therefore, to get the least profits, it means that therefore to get the least profits, it means that, or they have to produce 8.5 of the stake, 8.5 of the stake, and none of the fish. So they shouldn't produce any of the fish, but produce 8.5 of the stake. Or it shouldn't contain any of the fish, but should contain 8.5 of the stake. But please listen, this question, the graph is not drawn to scale. So if the graph it was drawn to scale, we would have gotten a clearer view of it. It could be that my answer here is wrong, especially the graphical, because the method and the approach is right, but because it is not drawn to scale, I don't know how we got this. This thing, we need a graph to verify 5 and 7. If we had a graph, we could tell the actual answer, but because we don't have a graph, we can't tell. Okay, so this is question 2. Any question?
How did you get the 10 and 0? Like 0 and 10.
How did I get the 10 and 0?
I didn't see it well. I don't know. Is it 7x? What?
Yeah, you're talking about
Yeah,
this side.
7x.
7x
7x
plus
plus
5y is equal to 70.
plus
And I
5y.
said that when y is 0, so 7x plus 5 bracket 0 is 70. So, this will give us 0. You
Oh.
divide it by 7, you divide it by 7. This cancels this. So, x equal to what? That's how I got 10.
Ah,
Please, you understand?
70 divided by 7, right?
Yes.
Sorry. I said 70 divided by 7. Or what?
Yes, please.
Okay.
Okay.
All right.
Okay. Please, can we continue? Hello. Hey. Yeah, I did ask. Question 3. This is a matrix question. It says that a company produces 3 products each day. The total production on a certain day is 60 tons. It is found that the production of the first product exceeds the production of the third product by 5 tons, whilst the combined production of the first and second is twice that of the third product. Determine the production level of each product using Cramer's rule. So they say that a company produces 3 products. Question 3. X, Y, and Z are the products. Okay. Now, the total production on a particular day is 60.
The first one, how we got the 60 or what?
Yes, yes.
You said Y and Z are 60 or
I said the question says that the total production on a certain day is 60 tons. So it means that when we add all the products we produce on that day, we will get 60.
we'll get 60. Okay.
You understand?
Mm.
Good. And they are saying that it is found that the production of the first product exceeds that of the third product by 5. So it means that the first product, which is X, is greater than the third, which is Z, by 5. So it means that when you subtract even Z from the first product, you get 5. That's the second criteria. Please, you understand what I just
Yes.
You understand? Okay, so
Mm.
that means that X is there, but we don't have Z, Y there. We don't have Y, but we have Z. Then let's look at the last. Now, the last one is saying that the total combined production of the first and second products is twice that of the third product. So, the total combination of the first and second is equal to 2 times the third. That's it. When we add the first and second, what we get is 2 times of the third. Please, you understand?
Mm-hmm.
So, when it looks like you're the only one here. When we bring this here,
Yes. It's-
x plus y
I'm
minus
even
2z
tired.
is equal to 0. We will do just this, then we break. Tomorrow we continue.
Yeah,
So
tomorrow.
we bring this here, we get x plus y minus 2z equals 0. So x plus y minus 2z being equal to 0. So these are the three equations. Now, this is a matrix question. It says that determine the production of each product using Cramer's rule. So using Cramer's rule, you have to resolve them into matrices. So the coefficients. We need the coefficients. So 1, 1, 1, 0, 1, minus 1, and 2 is equal to x, y, z. Oh, sorry. It is multiplying x, y, and z. And it will give us 65 and 0. Please, you understand?
Yes.
Okay. So from here, we start by solving the matrix. So we find the determinant of the main matrix. So A is the main matrix, and we are using Cramer's rule. So we repeat the first two, isn't it? And Cramer's rule, you take the diagonal. This will multiply this, and this will multiply this. So 1 times 0 times 2 is 0, plus this will multiply this will multiply this. So 1 times 1, negative 1 times 1 will give us negative 1. Then 1 times 1 times another 1 will give us plus 1, minus So when we are done, we do the second diagonal.
I
So
think I don't have this question though.
1 times 1
Did you send,
times
did you
2.
send it to me?
Yeah.
Oh really?
1 times negative 1 times 1. I didn't send it to you.
No, I don't have this question.
Eh.
Yes. Okay, you let's finish and then you send it to me later.
Okay. I just sent it to you. So 1 times negative 1 times 1 give us negative 1. Then 1 times 0 times 1 give us 0. So plus 0. Plus 0. So from here we get our main matrix. 0 plus negative 1 plus 1 will give us 0 minus. Here will give us 1, which will give us minus 1. 2 minus 1 is 1. Then 1 times 1 will give us minus 1. So our main matrix is minus 1. So now that we know our main matrix, we find the matrix X. And to get that matrix, we replace the totals with the X coefficients. So here will be 0, 1, 1, negative 1, and 2. So you repeat the first two. You repeat the first two. 60, 5, 0, 1, 0, 1. So here, the first diagonal of matrix X becomes 60 times 0 times 2, which is 0. Second one to 1 times negative 1 times 0, which is also 0. And then last one becomes 1 times 5 times 1, which is 5, minus 5 times 1 times 2, which is 10. 60 times negative 1 times 1, which is minus 60. Then 1 times 0 times 0, which is 0. So we get here we get 5. 0 plus 0 plus 5 is 5, minus this side will give us minus 50. So 5 plus 50, which is equal to 55. Hello?
Yes.
So I'm getting negative of the matrix X.